Hello children, in this class we are going to learn about rational numbers and their decimal expansions. Rational numbers and their decimal expansions. What are rational numbers? The numbers which can be written in the form of p by q where q is not equals to 0. The numbers which can be written in the form of p by q where q is not equals to 0. These are rational numbers. So when you are transforming this rational number into decimal, we are going to encounter with terminating decimal and non-terminating recurring decimal. Non-terminating recurring decimal. These are the two types of decimals we get when we change this rational number into decimal. Let's go for some examples where we get terminating decimals, and let us see where we get non-terminating recurring decimals, and let us see what are terminating decimals and what are non-terminating recurring decimals. In the first case, we shall go for terminating decimals. Terminating decimals are the decimals which stops. Terminate means stops. That means the decimal won't go till infinity. Let us see 3.75. Here the decimal has stopped after 5. There is no further continuation. If there is further continuation, say 1.1, 2, 2, 2, 2, 2, so on. That means 2 is continued, so on. So this type of decimals are known as non-terminating. Non-terminating means non-stopping, which are not stopped. Non-terminating recurring, that means 2 is occurring again and again, that is recurring decimal. And in this case the decimal has stopped, it is not going further, there is no continuation of the decimal. So these type of decimals are known as terminating decimals. This is terminating and this is non-terminating. Here we are seeing decimals. Let us say which type of which type of rational numbers are terminating decimals and which type of rational numbers are non-terminating recurring decimals. Let us see that. Take for example 3 by 8. Divide 3 by 8. P by q is nothing but dividing p by q. Here 3 is divided by 8. So here 3 is less than 8, that means you can't directly divide 3 by 8. So you have to put a point, take a 0 here, then you can divide 30 by 8. That is 8 3s 24, 6, 8 7s 56, 8 5s 40. Here we can't go further because the remainder is 0 and the decimal is 0.375. It is not going further, that means there is no continuation. So this is terminating decimal. 3 by 8 is a terminating decimal. If you go for 4 by 17, that means you are dividing 4 by 17. Let us see what type of decimal it is. Divide 4 by 17. Here again 4 is less than 17, you can't divide 4 by 17, so put a point and take a 0 here. 17 2s 34, 6 17 3s 51, 9, 17 5 85, 5, 17 2s 34, 16, again put a 0, 17 9s 153, 17 4s 68, again 17 1 17, 3, 17 1 17, 17 7s 119, like that the decimal is continuous, and after some time again this is repeated, that is 2 3 5 2 9 4 117, that will be repeated again. So this is 4 by 17 is non-terminating recurring decimal. This is terminating decimal. So by division we are going to know which is terminating and which is non-terminating recurring decimal, but without actual division also we can know whether the given fraction or whether the given rational number is terminating or non-terminating recurring decimal. Let us see how we can find out that. We have to go for the prime factorization of the denominator, that means which we have discussed in the earlier classes. We have to go for the prime factorization of the denominator. Say 8 here, that is 2 4s, 2 2s, 2 1s, that is 2 cube. In this case the prime factorization of the denominator is 17 power 1, because 17 is prime number, so you will get 17 power 1 as the prime factorization of 17. Whenever you get the prime factorization of the denominator in terms of 2 power m into 5 power n, 2 power m into 5 power n, then the given rational number is terminating decimal. That means you need to get 2 or 5 or both in the prime factorization of the denominator. You have to get 2 or 5 or both, but you should not get other than 2 and 5 in the denominator. If you get other than 2 and 5 in the denominator, that will be non-terminating recurring decimal. Let us see that once. If we have 7 by 225, in this case what is the prime factorization of 225? That is 3 1s 3, sorry, 3 7s 21, 3 5s, next 3 25s, 5 5s, that is 3 square into 5 square is the prime factorization of the denominator. If you have other than 2 and 5, here we have 3, here we have 3 in the prime factorization, so this is non-terminating recurring decimal. That means you are getting a number which is other than 2 or 5 in the denominator, then that will be non-terminating recurring decimal. If you get only 2, that is 2 power m, that is also terminating decimal. If you get only 5, say 5 power n, that is also terminating decimal. If you get 2 power m into 5 power n, that's also terminating decimal. If you are getting other than this 3, if you are getting a case other than these 3, then that is non-terminating recurring decimal. This is how we can find out whether a given rational number is terminating decimal or non-terminating recurring decimal by taking the prime factorization of the denominator. Let us go for one more example and let us conclude the class. Fifteen by 176. 15 by 176. Let us divide 15 by 176 and let us check whether it is non-terminating or terminating decimal. Before that, let us go for the prime factorization of 176, that is 2 8s 16, 2 8 16, 2 44s, 2 22s, 2 11s, 11 ones, that is 2 power 4 into 11 power 1. 15 by 2 power 4 into 11 power 1. Here we got other than 2 power m or 5 power n or 2 power m into 5 power n, that is 11 power 1. So this is non-terminating recurring decimal. Non-terminating recurring decimal. Let us verify this by actual division. Here you can't divide 15 by 176, so take a point, a decimal here and put a 0 here, and again this is less than 176, so put a 0 again. 1500. Now we can divide this. Seven 6 42, 7 7 49. 176 8s. 8 6 are 48, 8 7 are 56, 4 60, 8 1 are 8, 14. 14 not 8. That will be 92. Put a 0 because we have taken decimal here. Again go for the 30. 176 into 5, that will be 880. 40. Put a 0 again. 2s. 352. 48. Put a 0 again. 2s. 352, that will be 10 minus 2 8, 7 minus 5 2, 4 minus 3 1, 128, again 0. So this is going on. So this is non-terminating recurring decimal. If you are getting the prime factorization of the denominator other than 2 power m into 5 power n, then that will be non-terminating recurring decimal. If you get the prime factorization of the denominator as 2 power m or 5 power n or 2 power m into 5 power n, then that will be terminating decimal. In the next class we shall go for non-terminating non-recurring decimals, that is irrational numbers. With this I am concluding the class. Bye children.